classification of computer simulation methods. Today, widespread approaches of computer modeling are molecular dynamics (MD) and Monte Carlo (MC), and also there are hybrid techniques that combine the features of both. MD allows to anticipate an elasticity, plasticity, or distraction without any changes in the procedure. In addition, MD has another name as atomistic modeling, which allows simulate materials of nanometers size, analyze and understand the motion of each atom in the material, understand how material exposed deformation, phase changes, also extracting information from atomistic dynamics. Sometimes MD is called the first principle approach to understanding the behavior of atoms and determining interatomic potential, how atoms interact. All properties of materials, infinity possibilities and problems. The next most important type of computer simulation is Monte Carlo, which was named after the city. Monte Carlo, like MD, will be used to solve some problems. Unforeseen risks is science, technology, in finance, etc. In comparison with MD method, in this method the process is modeled by generating random processes, objects, quantities, which in turn is repeated several times, and one of the basis of obtaining random data the probabilistic characteristics of processes being studied or the problem being solved are calculated. During the modeling, these random objects can be natural, which is part of a simulation of a real system, or introduced artificially. Often in many cases of simulation, random objects are introduced artificially. Also, the Monte Carlo method is actually used for modeling physical processes, for solving quantitative problems of science, technology, and also in materials related science, where they are used to develop and analyze new materials and structures. In addition, the Monte Carlo method is applied to the design of virtual materials, which in turn allows you to get more data than physical experiments. Thus, the MD and Monte Carlo are widespread approaches of computer modeling, which in turn allows to study the properties of materials, analyze and understand the motion of each atom in the material, determine the interatomic potentials, how atoms interact, and also apply when studying random structures and graphs arising in statistical physics, probability theory,